We are going to present you the neural network training and testing for Van de Bus continuous reactor for cyclopentanol. For that, first we're going to simulate the reactor behavior by implementing the differential equation. Then we are going to generate training data, barring the condition of the reactor once it reaches the steady state. And with that data, we are going to train and test the neural network and see if the predictions are correct. For the first step, we have the steady state profile, and we can see two main characteristics. That when it reaches a maximum concentration and the flow rate keeps increasing, the concentration decreases. And the second one is that when the temperature increases, the minimum concentration decreases. And for the dynamic of the reactor, we can see that it's nonlinear because it has an inverse concentration behavior when the flow rate increases. And we can see that the rate of concentration is not constant but change over the time.
To generate useful dynamic data for neural network training, we selected parameters that ensure variability and process stability. The sampling period was set small enough to capture the reactor dynamics without producing excessive data. A total of 400 sampling points were chosen to provide a sufficiently long run with multiple perturbations. We began a steady state for 25 samples to establish a baseline. The flow rate was randomly changed every 50 samples to create a diverse operational scenarios. Finally, after the 100th sample, the temperature was changed every 100 samples between 120 and 150 Celsius degree to introduce a thermal disturbance after the initial flow variations.
Because the system is dynamic, we decided to use a neural network that takes memory into account. So we implemented a recurrent neural network. We compared two architectures, LSTM and GRU, and tested different configurations such as dropout and regularization. The best performance was achieved with GRU combined with L2 regularization, reaching the values here presented.